Next we have trio and erythro nomenclature. Now this type of nomenclature is done in this type of molecule, that is when we have two carbons and they have groups like this, A, B and X, A, B and Y. That means two groups are common in case of the two carbons and the third group is different. Suppose I can give you the example like this molecule. In case of this molecule you have two groups common. This is red one, this is blue one, red one, blue one, and these two groups are different. So in this type of molecules we can do this trio and erythro type of nomenclature. Now how we do this thing? We have to write down the molecule in Fischer projection formula, and then we have to see. Suppose if we have this molecule like this. Suppose these are two isomers, these two are the chiral molecules. So in case of what we can see here, that all these two groups are similar. Suppose hydrogens are similar. So if we have to see this, divide this molecule, and then we see that become similar groups. The hydrogens are similar, they are on one side, and bromine and OH, these two are two different groups, but they are also similar. They are similar, that means they are bigger groups. So these two groups are on one side. So these two isomers will be called as erythro isomers. Erythro, that means similar groups are on the same side, that will be called as erythro, this one. And then if we have the molecules like this, suppose if we change the configuration like this, then what we will get? We will get this compound. So these two molecules are also isomers. That means we can write down 4 isomers from these two molecules. And in these 4 isomers, what we have found that in case of these structures, similar groups are not present in the same side of this plane. So that is why this will be given the trio isomers. That means we can have, in this type of molecules, we can have 2 erythro isomer and we can have 2 trio isomer. Now what is the application of this? If you study some reactions like addition of bromine to alkene or addition of hydrochloric acid to alkene, this type of in those type of reactions you will get the products like this. Okay, and then there you will find this type of trio and erythro nomenclature, and this type of questions may also come in the exam. So this is about trio and erythro nomenclature. Next one is D and L. D and L nomenclature. Now this is not nomenclature, it is like called a notation, DL notation. Okay, so D and L, 2 types of DL and L is there. It is written in the books, you will find. One is small d and small l, one is capital D and capital L. Now I am going to talk about capital D and capital L, small d and small d I will talk later. So capital D and capital L, this type of nomenclature is done in case of the monosaccharides or those type of compounds like glucose, fructose, those type of compounds. This type of example is written. This type of nomenclature is done, where we have lot of chiral carbons, and here we have different groups like this. If we write down the structure of glucose, then it is like this. So in this structure, what we have seen that this is the most oxidized part. That means this is the aldehyde group, this is here it is alcohol, so this is the most oxidized part. So we have to write down the structure in Fischer projection. This is Fischer projection, and in this structure, this CHO group, that means this should be on the top. That means the most oxidized group should be on the top. And accordingly, if we write down the structures, then how many chiral centers we have to see. This is one chiral center because 1, 2, 3, 4 different groups are there. This we can take as a one group. This is a chiral center where four different groups are there. This is one, this is one, this is one, and this is one. So this is also a chiral center. This is also a chiral center, or it is also called asymmetric center. So the carbon, we have to see the configuration of the carbon which is highest numbered asymmetric carbon. That means if we give the numbering to this, if we give the numbering to these 4 asymmetric carbons, then this one used to get number 4. That means this is the highest numbered asymmetric carbon. So if in this highest numbered asymmetric carbon, the configuration of this OH we have to observe, if it is present on the right hand side, then it will be given as D, capital D. And if it is present on the left hand side, then it will be given capital L. This is the simply D and L nomenclature. You have to write down the monosaccharide structure in the Fischer form, and then in the Fischer form you have to see the asymmetric carbons and give number to them, and highest numbered asymmetric carbons configuration you have to observe. And in the highest number of asymmetric carbon, if OH is present on the right hand side, it will be given the name D. That is why we used to write D glucose or L glucose like that. And then it is, if it is present on the left hand side, it will be given that is L configuration. So this is about DL notation. Up to this we have discussed so many type of nomenclatures today. Suppose we have discussed DLN, trio and in vitro, RESI, and then RNS nomenclature. Then we have also discussed earlier EZ and cis-trans type of nomenclature. So all these type of nomenclatures are necessary to understand and to show some examples on this. And then because this used to come in the exam, as well as these concepts of this type of nomenclature is needed in solving reactions where you have to write down the mechanisms why some erythro product is found or why some trio product is found, like that. So this is about the different types of nomenclatures present in this stereoisomerism that is required in your syllabus. And in the last class I have discussed a little bit about optical isomerism or optical activity. I have told you that enantiomers have different optical properties. Now what is that optical isomerism? We will briefly discuss this thing. Optical isomerism means, suppose if we see the normal light that is coming from sunlight or any bulb or some normal light, that normal light have all the directions, all the directions the normal light used to move, okay, from the source. So what we can do, we can use some prism or special type of polarizing prism, and if we use that prism, then what will happen? This becomes one direction. So one directional light you will find. And if we have a sample, suppose here we have a sample means it is the organic compound, and we allow this light to pass through this sample, then what that sample can do, it can rotate that light by right hand side, or it can rotate the light by left hand side. So this type of property is shown by organic compounds which have this chiral carbons. That means the carbons which are having 4 different types of groups, or enantiomers or diastereomers, they have this type of property. That means if we make a solution of that compound and we place it here and we pass that polarizing light through that sample, then that light will rotate. And this rotation will be different in case of enantiomers, or it is different in case of diastereomers. That means if one enantiomer can rotate towards right, another enantiomer will rotate towards left. So this is the property that is different in case of the enantiomers and diastereomers, by which we can distinguish in between them. So this is, there is a practical also there in your BSc level, that is practical by using polarimeter. The instrument is called polarimeter. You have to make one solution of glucose and you have to see, glucose is an optically active compound, so glucose, you have to see that rotation, you have to calculate all those things. You have to do that practical in the laboratory. So this, in this here you will get to another type of nomenclature, that is DM, small d and small r. Now this small d and small l means if the light rotated by the molecule towards right hand side, this will be called as dextrorotatory, and that is why it is given small d. And if it is rotated towards left, it will be called as levorotatory, so it will be named as L. So today I finish it here, and I will discuss more thing about optical activity in my next class. Thank you.